I bought a large pillar drill made by Pollard in an auction without seeing it running, and guess it may have been made in the 1950s, probably in Leicester in the UK. As a drill motor is three-phase, I only have a single-phase supply. The first step was to buy a single to three-phase converter with the recommended EMC filter. Here's the offending item. Wire size is looking a bit small. I think it'll be okay for a test. We've got Delta Star arrangement. Start. Stop. Change the control speed. We're from 0 up to 50 Hertz and full turn. And reverse and forward works. Uses the deceleration time to bring it swiftly to a halt and turn around. And emergency stop. Having obtained the wanted control using prototype wiring, cabling using the 7-core cable and 7-way connectors I bought was worked out. This is shown in red on the whiteboard diagram I used. 3/1 means number 3 cable, first core, and so on. In anticipation of fitting a guard at some point, a safety interlock was added to the circuit. The interlock seen here with its lid off at the bottom of the picture will prevent the motor starting unless the guard is closed, locks the guard when the motor is started, and only unlocks when the motor stops. The control drive circuitry was made up on the bench and installed on the drill. The large red plug underneath the box here is a 3-phase output for the drill motor. In the meantime, the workshop floor, scheduled to be lowered anyway, was dug out and a steel frame with 20mm studding in the corners to fit the drill base welded up and concreted in. The drill was then installed, bolted down and levelled. The drill was then tested out to see how it performed. This shows a 3/8 10mm pilot hole, followed by an 1.25" 31mm bit drilling into an old 25mm steel plate. I made several attempts at sharpening this bit, but I couldn't get it to cut equally on both flutes. Whether that's down to my sharpening, being out of practice, or perhaps down to the play in the bearing or some other problem, I'm not sure. One of the problems is this cover. You can see it's been knocked about a lot. Don't know why. Well, could be because, as it is, the gears are hard to change for the auto feed. I suspect that's the reason. This is where a selector fork shaft moves up and down in, or rather doesn't move up and down in. And as I've unscrewed it, you can see that this, which is the adjuster for the fail-safe clutch, has been rubbing on the top here, and also this is completely cracked, which doesn't help for aligning anything. See the movement needed. The other thing that has been knocked about, possibly as part of the same reason, is this piece. This is just a cover, really. There is a bolt here a nut that can need adjusting. This lever is knocked by a peg here when the whole thing comes down to put it out of automatic feed. I can probably demonstrate that. There we are, it's just tripped it. Apart from the auto feed gearbox cover causing problems selecting feeds, the other problem is that there is some 6 thou 0.15mm play at the top of the drill bit, as you can see here. The testing shown earlier used a slow feed rate, but it took quite a few attempts to get it into that feed gear, and once in, it took even longer to get it out again. I didn't resort to hitting it to shock the gear selector free like the previous owners, so this left only the fastest of the feed rates available under normal operation. The plan is to make a new cover from solid aluminium to restore the use of all 3 auto feed speeds, and find and fix the source of the play in the shaft of the drill bit to improve the hole location, size, and keep the drill holes vertical.